In order to understand radioactive decay, consider the following example. For example, here you have a carbon, and as soon as it will release a beta particle from its nucleus, it will change into nitrogen. So we can define radioactive decay means the changing of an element, radioactive element, into another element after the release of a nuclear radiation is known as radioactive decay. Okay, evidence of the randomness of the radioactive decay we can found. Here we have a lead container, for example, and inside the lead block we have a radioactive substance or element. So if we place here a GM tube in front of it with which a counter is attached, so this is GM tube and here we have a counter, then we will observe that the count rate, for example, it started from 250, then 260, then 245, then 275. This means there is a fluctuation in count rate. So this fluctuation shows that the radioactive decay is a random process. Each count rate represents the decay of a particular nucleus. This shows that radioactivity is random and spontaneous in nature. For example, what is meant by spontaneous nature of radioactive decay? It means radioactive decay does not depend upon environmental factor such as pressure, temperature, electric field and magnetic field. Second, how we can demonstrate its random nature, that is radioactive decay random in nature. Consider an example that, for example, in a class you have 30 students. As a teacher, you can't predict which student is going to speak first, but you are sure about that each student has a definite probability to speak. Yani probability of speaking for each student is same. For example, in a sample of radioactive elements, you have millions of atoms or nucleus. So which nucleus is going to decay first, you can't predict. But what you can predict, that the probability of decay for each atom is constant, or in other words, a process in which the exact time of decay of a nucleus cannot be predicted. Yani time of decay cannot be predicted. It means which atom is going to decay first, we are not sure. But each atom has a definite probability to decay. This curve represents the random nature of radioactive decay. See here that peaks are there, any elevations and depressions are there.